Okay, so we already graphed sine and cosine functions, right? And so if we just go back to the sine and cosine function, let's take sine, right? Notice sine is 0 at what points? Sine is 0 at 0, 180, and 360, right? And where is cosine 0? 90 and 270, okay? Now, if you wanted to graph tangent, right? What is the definition of tangent? What is tangent? Tangent is sine of x over cosine of x, okay? So, in the first section of this chapter, we did trig geometry style, and we talked about, opposite, adjacent, and hypotenuse. Once we are in section 2, those terms, opposite, adjacent, and hypotenuse, are going to be wiped from our vocabulary forever. There is no longer going to be opposite, adjacent, and hypotenuse. It's going to be, facing the vertical side versus, the vertical side versus the horizontal side. Because our angles are always like this, right? This is always my angle. So when I say that archaic term opposite, I always mean, I'm always referring to this segment, always, okay? So I'm not going to say opposite anymore. I'm just going to say vertical. And when I say horizontal, when I say adjacent, see, I can't even say it anymore. I'm always referring to that same line, right? That same segment. So it's going to be the vertical and the horizontal, okay? No more adjacent. Vertical and horizontal. What we used to call opposite and adjacent are now going to be the vertical and the horizontal. Now, and the radius. Now, so let's define tangent as sine over cosine. Okay, so this is a rational expression now, right? You have a variable in the denominator. Can the denominator ever equal 0? No, it's you have, what do you have when the denominator equals 0? A vertical what? A vertical asymptote, right? Do you remember from chapter 8? Like where you have like y equals x over x plus 2? Where the denominator equals 0 gives you a vertical asymptote. So here, when you have sine x over cosine x, wherever that denominator equals 0, you have vertical asymptotes. So let's think about that. Where is cosine of x 0? Well, we just said here that cosine of x is 0 at 90 and at 270. That means at 90 degrees and 270 degrees, we're going to have vertical asymptotes, okay? So, to repeat, tangent of x is undefined everywhere that cosine of x is equal to 0, all right? At these points, the graph of tangent of x has vertical asymptotes. All right, so that's going to be important. Now, what about the period of the tangent function? What was the period of the sine and the cosine? 0 to what? 360. So it's 360 or 2 pi. The period of the tangent is just 180. Okay, so the period is 180 or pi. That means the tangent completes one cycle in a length of 180 degrees. All right, so let me trace out one cycle of the tangent. This is one cycle of the tangent. Okay, it goes from -90 to positive 90, how many total degrees is that? 180. Okay? And then from 90 to 270, that's another 180. It completes another cycle, and here another cycle, and here another cycle. All right? So this has a length of 180 degrees or pi units. All right? And you can see that at 90, there is a vertical asymptote. At 270, there is a vertical asymptote. At negative 90, there is a vertical asymptote. Those are all the points where the cosine would have been 0. Okay? All right. So, since the full period is pi or 180, to solve for the period of a tangent graph, we say pi over b or 180 over b. Remember what b was? B is the number, b is the coefficient of the theta, right? So here, b is the coefficient of the theta. All right. Now, how do you figure out where you're going to start and where you're going to end? So, do you remember with the sine and cosine, we use this equation, right? Because the one period of the sine started at 0 and ended at 360. In the case of the tangent, this is what we're going to use. All right, because one period of the tangent starts at negative pi over 2 and ends at pi over 2. And magically, this also identifies the asymptotes for us. Okay, so let's start with the very first one. Okay? All right, so here's our x-axis. Oh, one thing I didn't mention. So remember a tangent, sine and cosine, remember, are restricted because it's always a smaller number over a larger number, right? It's always restricted. But for tangent, there is no restriction on the value of a tangent. It could be 3 over 4. It could be 4 over 5. It could be 4 over 3. There is no restriction. So the range for the tangent it goes up to infinity and down to negative infinity. So there is, it doesn't have a limited range. Okay, so here is the x-axis here. What we're going to do is we're going to do negative pi over 2 less than this, all of that. In this case, it's just theta. Oh, you know what? Let me do degrees first. So let's do negative 90. Yeah, which is 90. Oh. Right? So yeah, so negative 90 less than theta less than positive 90. What this tells me is the cycle will start at negative 90, end at positive 90. So I start here. Okay, so this is negative 90, 1, 2, 3, 4. This is positive 90, just like before. Where's the y-axis going to go? In the middle. Okay. Now, these numbers are the asymptotes. So there is a vertical asymptote here. There is a vertical asymptote there. Okay? Now, at 0 degrees, how much is the value of the tangent? So tangent of 0 is 0. So here it's 0. Okay? So how big is this? What is this one? This is 45 degrees, negative 45 degrees, right? At 45 degrees, what's the tangent? Which is, no, the tangent at 45 degrees is 1. Root 2 over 2, root 2 over 2, so it's 1. The tangent at negative 45 degrees is how much? The number is going to be 1, but is it positive or negative? Negative 1. So this is what the tangent will look like. So there are vertical asymptotes here, and it looks like that. Okay? All right. Now, let's see what's going on here. Look at this region from 0 to 90 on the unit circle. 0 to 90 corresponds to what quadrant? First quadrant. Is tangent positive or negative in that quadrant? Positive. So you see how the graph is above the x-axis? Now this region here, 0 to negative 90, 0 to negative 90, that corresponds to that quadrant. Tangent is negative there, and you can see the graph is below the x-axis. Okay? All right, so what was the period for this one? 180. And we're not gonna, it's undefined, so we're not gonna talk about the amplitude. I should have taken that out. Okay, so let's take a look at this one now. So let's do this one from negative 2 pi to 2 pi. We're gonna put 2 theta in there. So when we divide everything by 2, we have negative pi, theta, pi. All right? So we're going to start at negative pi and end at pi. Okay, so how much is the period of this one? Period is pi over 2. Wait a minute. Okay, so I made a mistake. I'm sorry, I got carried away. These are wrong. Okay, so we say, yes. So it's going to be negative pi over 2, 2 theta to pi over 2. And now I divide by 2. No, I divide by 2, so it'll be like 1 over 2. I have to, it's 2 theta. I need to divide by 2 in order to make it 1 theta. Dividing by 2 is the same as multiplying by 1 over 2. Okay? So this is going to be negative pi over 4 theta to pi over 4. Now, for the period is pi over b, so it's pi over 2. So the period is pi over 2. All right, so we're going to go from here to here. Right, but now this one is tangent of 2 theta, so it's a modified period. All right, so this is going to go from negative pi over 4 to pi over 4. What's the center mark? 0. And now between 0 and pi over 4 is pi over 8, and this is negative pi over 8. So the y-axis is going to go here, right? Okay, now the vertical asymptotes are going to be where these numbers are, the endpoints, so at negative pi over 4 and pi over 4. Now, at 0, right, when theta is 0, so look here, y is equal to 3 tangent 2 theta, right? So, when theta is 0, here I have 3 tangent 2 times 0. How much is that? That's 3 times tangent of 0, which is 0. So here it's 0. Okay? Now, these 2 points at pi over 8 and negative pi over 8, it's going to be either, like the maximum or the minimum. So it would have been 1 and negative 1. But since I have a 3 in front, this will be 3, and this will be negative 3. It's not amplitude, it's just the 3 makes it a little bit narrower, less curvy. So it'll look like this. Okay, do you see how it's a lot less curvy than the first one? That's what that A in front of the tangent does. Okay? All right. So now, let's go to the cotangent. Cotangent is defined as cosine over sine. So it's undefined at all points where sine of x is equal to 0, because you don't want the denominator sine of x to be 0. So where did we say sine of x was 0? At 0, 180, and exactly 0, pi, 2 pi. Okay? So this is at 0, 180, 360, otherwise known as 0, pi, 2 pi. So those are the points where you have vertical asymptotes. So let's fill this in here. The parent function that we're talking about is cotangent of x. All right. The range is all real numbers. Okay. Okay, so the domain, this is all points where sine of x is not 0. Okay, so wherever sine of x is not 0. The period is also pi, or 180. But this time, it doesn't start from negative pi over 2 to pi over 2. It starts from 0 to pi. Okay? So, instead of doing bx plus c, going from negative pi over 2 to pi over 2, and we're now going to go from 0 to pi. Okay? So, let's do this one. All right, so let's see how much the period is going to be. The period is going to be pi over 4, because that's pi over b. All right, so let's see what else we're going to do here. So it's 0, 4 theta to pi. Now, divide everything by 4. So this is going to be 0 theta pi over 4. All right, so we're going to go from 0 to pi over 4. Here we have asymptotes. What's in the middle of 0 and pi over 4? It's what? It's pi over 8. Whoa. The y-axis is at 0, right? So this is pi over 8. What's the first tick mark here between the 0 and the pi over 8? Pi over 16. It's half of it. And that next one is pi over 8 plus pi over 4 times 1/2. Right? So how much is that? It's 3 pi over 16. So this is 1/2 times 3 pi over 8. So that's 3 pi over 16. Okay? All right, so now, same situation. The center is going to be 0. The y-axis is at 0 here, right on the asymptote. At the center, it's 0, but now it's positive on the left and negative on the right. So at pi over 16, it's going to be positive 1/2. And here it's going to be negative 1/2. So it's going to look like this. Okay, so it goes the other way because we're taking two different coordinates. We're taking two different quadrants. Okay? All right, so that's cotangent. Okay, now, what about cosecant and secant? Yeah. So, remember, cosecant and secant functions are just 1 over sine x, 1 over cosine x. So, if cosecant is 1 over sine, that means it has asymptotes where sine of x equals 0, right? And cosecant has minima where sine has maxima. It has maxima where sine has minima. So take a look at this one. This is the sine function here. This is sine of x. Okay? Wherever sine of x is equal to 0, you have vertical asymptotes. All right? And then the actual cosecant graph is in the green here. These are the actual cosecant graphs. Okay? Makes sense? It's kind of pretty. All right? Now, secant is the same thing but with the cosine. So it has asymptotes where cosine is 0 and minima and maxima opposite to the cosine. So what we do is you draw the cosine, okay? You put asymptotes where the cosine is 0, and then you draw your secant. So why don't we just draw one? Okay, so now this is secant. Does that go with cosine or sine? Cosine. So I'm just going to draw a cosine. Let's draw a cosine. All right, what's the period of this going to be? The period is going to be 2 pi over b, which is 2 pi over 1 over 3, which is 6 pi. And I'm going to say 1 over 3 theta, and I'm going to bound it in between 0 and 2 pi. Okay? So multiply everything by 3. I have 0, theta, 6 pi. So I'm going to go all the way to from 0 to 6 pi. The middle is 3 pi. Quarter way is 3 pi over 2. And then it's 9 pi over 2. Okay? All right, so what I'm going to draw now is the cosine. And remember, there is an amplitude of 2. So where's the y-axis? Let's put the y-axis down here. Okay, wait, no asymptotes just yet. First, we're going to draw the cosine. So let's draw the cosine. At 0, what's the value going to be? Try again. 2. Right? And then it goes from maximum to 0 to minimum, 0, maximum. All right. So we draw this. Now Now you put asymptotes where the cosine is equal to 0. So asymptote, asymptote. Okay? Okay, after this, we're going to draw the secant. All right, so up here, it's going to be just the reflection upwards, right? So there, here, and on the left. I mean on the right. Okay? Now, the red one is not part of the secant. That's just the cosine. That was just there for us as a guide. So technically, I could erase the red one. All right? That's really the cosine. I'm sorry, that's really the secant. All right? I'm going to leave it there for you guys to see. All right. I have time. I'm going to do one more. Let me open up a grid here. Yes, I'll go back in a minute. But let's see. All right, so let's draw cosecant of 2 theta. And you know what? Let's put a 3 in front. Okay? Or you know what? Let's make it a half. Make it a little bit more fun. So y equals 1/2 cosecant of theta. All right, so what is this like? The sine or the cosine? This is like the sine. What is the period? Two pi over 2, that's just pi. All right, so we're going to go from 0 to pi, right? All right, so let's do this. 0 to theta to 2 pi. So it's going to go from 0 to pi. All right, so here's 0, pi. What's the halfway point? Pi over 2. And here, pi over 4, pi over, how much? 3 pi over 4. All right, so if you start from 0, whatever this is, right, since that's the first quarter, that's 3 times it because that's the third quarter, right? Okay. The y-axis is going to go here. All right, now, what are we going to graph first? First, we're going to graph our sine, right? So let me graph the sine. All right, so at 0, it's 0, and then at pi over 4, it's how much? The maximum, which is a half, and then 0, and negative half, and then 0. So here's my sine. I wanted to get it. Okay, here we go. I want it. Okay. There we go. That's the sine. Okay, so now I'm going to put in my asymptotes. Where? At 0. At pi over 2. And at pi. And here comes the cosecant. They look like U's. They touch at that one point, and then they look like U's. All right? That's it. Okay? That's all. All right, so this will be it. Now, the homework, this in its entirety will be due Monday. Is that right? Yes. Okay? It'll be due Monday. And check Haiku for the schedule for the rest of the chapter, because once we finish this chapter, we're going to go into chapter 13, and you're going to have a test on that before the end of the year. Okay?